All right, this is the tutorial. We're showing how once you've made your spoiler for your car, how you can do some of the testings and the evaluation, the justification that you met the certain design criteria for your car. This is the model that you have over here. Now I've made a very eccentric wing here with a sticker, which we can do later to show that is one of the design criteria. But this one over here, I have it with the model of the car, and then I put that wing into its own file so I could test it, because I didn't want to test it with the other car around here. And I'll show how I do that. I start a new file. So this is a saved file. I've saved this over here. So we're assuming here that you have your wing fully built, saved, all good to go. You're not going to modify it anymore. You start a new file and you go to the insert and you insert derive, as in like a derivative of another design. If you press this, we have to save our design. So this will be spoiler tutorial v3. So you have to save your file when you do the derive, and then it should load up. Let me just check, are we recording? You got to find the file, so stage 6. This file over here was the 2024 F1 template. Now I think it was this one. Select. Are we recording? Yes. This file will load up, and now so this is the new file I made, and it should show me the other template we had. Let's give it a chance to load. Before I tried to do the derive thing, I didn't save my previous design because I did like hide and hide and reveal stuff, so I just have to save my original design. Then let's see. Okay, so now we have this. We get this little box over here on the right called the derive. So we're saying which objects in this model that we opened do we want to bring into our new thing. Well, I've labeled it over here as we just want the rear wing. I can press this and we'll see what this involves. This just involves one body over here, the rear wing. But you can also bring in other things like shapes and components. And then we will, we can also place the object at the origin, because this wing over here is all the way at the side of the back of the car. When we bring it into our new design, we're saying, do we want this object to be in the middle, or do we want it to be in the original location it was? So I'm going to say place at the origin. I'm going to press OK. And then in our new spoiler tutorial v3, we should have just our wing load up. Did it? Oh, there it is. So there is our wing that we have here. So now we can use this to do some of our tests. If we look over here, so this has this little arrow attached to it. This little arrow means it's a derivative, or it's been derived from another model. If I were to change this in my original model, when I do all my savings correctly, then this model over here will change. Now it's kind of like when you have two students have like a Google Doc open. When one of you modifies it, it's going to modify the other one. But you can sometimes get a case where somebody modifies something and they try to save it, but someone else has saved it and they like almost corrupt each other. So in general, if you're doing this process and you want to change the original design, make sure you close. So we would want to close this spoiler tutorial if we're going to modify the original design. And then when we reopen the spoiler tutorial v3, it will look at what the latest specs are for this spoiler, almost like when you load up Clash Royale and it does the updates. Now, I'm going to modify this at some point in my future design, and I don't want my modifications to affect my original design. So another option we have is, with this arrow here, if we right-click this wing, we can, which button do we press? We can unlink it. Where is it? We press this break link button. If we press this break link button, it's going to no longer look for updates on the previous model. So, like if we want to change the dimensions of this and we just want to do it with just this part, we don't want to open up the whole file, we can break this link. And then this is like the one that I have open. What's happening over here? This is like the one I have over here that I was working on previously. See how it doesn't have the arrow here? Because I've already unlinked this one because I've been doing some testing over the week. Okay, so now what is your design criteria for your assessment tasks? Because we have to, the whole point of this tutorial is we're showing how we can measure certain design criteria. Someone give me a design criteria, please, that your spoiler has to meet. Not all at once, please. Come on, look at the document, please. Yes. Go on, what is it? What? What is a design criteria now that I've actually given it to you on a Google Classroom? Someone give me a design criteria.
It must fit the car model.
It must fit the car model. So, how I would demonstrate it must fit the car model. This is where I would show a picture like this, and I would literally go around and show like screenshots how the model fits over here. This design is not the best because over here there's this gap over here. So this would not get full marks for that design criteria. But probably a 8 out of 10 for how well it fits the model, because it has this line over here matches, and down here it matches inside this slot. Right, so I would show, just by images showing the spoiler on the model, take pictures, and I would put that in my folio. What's another design criteria? So off the ground. So the ground is where the bottom of this wheel is for Formula One car. So in this case, I can't measure just the spoiler. So I will have to use a measuring tool. I'm going to have to use the inspect tool. So I'm going to show when I do the inspect tool, I can inspect from this line over here, and the line I'm going to measure, I should have my origin should be over here where the wheels are. So if I press this over here, and now it did a measurement over here. So my spoiler actually is too high. That's fine. This is a quick demonstration I did. I would change my design to make it spoiler, but this is the number I have there. Also, when you go into drawing view, I showed you on the, if I do it in orthographic projection, I could also find that dimension there as well for the maximum height, which I can do that by going design, drawing from design. If it should load up. So this also ties in because this is going to show the other one, which shows the width. What's the width of the spoiler? So 1,200? Yeah? Yep. All right. Yeah. Okay, so I have the car over here, and I only need this view for the sake of this, because on Fusion 360, I don't even need the, what's it called? I don't need the scale to actually matter for this part, because whatever dimension I pick, it's going to when I pick the dimension, it's going to automatically pick the size of the design. So I'm picking the very top of the spoiler, and I want to pick this part over here, and I bring this out like that. If I see this drawing, that's 1,050 millimeters from the ground. Now yours will be better, yours will be under 1,000. Same thing for the width. I can press the dimension tool, I can press this line over here, and then I can press this line over here, and then that's the width of my spoiler. So the width of my spoiler is perfectly fine. Those are two easy dimensions. That's like C level to get those two dimensions out, because they're fairly easy. The more difficult one was the, well, doesn't match with the design, because you need to do some design creativity. Then we have the spicy one, which is about the cross-sectional area. What is that? What was the number? It says how much lifting surface area is needed. How much? 2 meters squared. Okay. So you could get this shape over here. Now mine's a nice rectangle. I could just find that length. I could plug into inspect. I can inspect this length over here, and then I know that length is 498.12, and then I can multiply it by pressing, I can multiply by this one. But some of you are going to have nice curved wings. If you look at the wings that Red Bull has in the Formula One, it's like multiple curves all over the place. And we actually have a way to test that. We can actually select the whole wing. We can press inspect, we can press this whole surface. And if you press the surface, the area is already put out there. Now this is 5.629 e to the 5 millimeters squared, which means that is it's in millimeters squared, so it's like millions of 500,000 millimeters squared is what this is. Now we need 1 meter squared. I'm pretty sure a meter squared is 1,000,000 millimeters squared, because 1,000 times 1,000. So this is only half the cross-sectional area in this design over here. So that's your first hint you get when you're doing your spoiler. You're going to have to do something else to get twice as much lifting surface. What can you do? Make another one, yeah. You can make another one. Also, if you curve it, it's going to be slightly more area as well, because even though, yeah, you could do 2 curved wings. And when you're measuring it, notice how I'm not measuring the top and the bottom, I'm just measuring the top of the wing. So when I'm demonstrating this value, I'll show you that I've selected that, and I'll show this value over here, and then I will explain that this in millimeters, how much that is in meters squared. That's me proving that. What else? Is that it for the design criteria? Yes, so again, I have Prime Energy Drink over here. I could show, if I look at the top livery over here, I can show, and this is a chance you have some fun. Put a sponsor that's appropriate, nothing that it's inappropriate for school sense. But over here, here's an example. Prime over here clearly can sponsor my car because their logo is put there. How are you going to put that logo in? You are going to go to the insert, you're going to go to the decals. And when you do the decals, I'm going to say insert from computer. Now, do I have Prime? Oh, it's right here. Prime logo is the file I have. So I downloaded this and put it into my drive. And then when you do that, you press the surface. Let's say I want to put the primes over here on the side as well. Get that extra Logan Paul money. And over here, rotate it to what makes sense for your car, just for your image. Because everything is all about money all the time. Prime, notice how in this drawing, how the prime is spawning at the back here, like a demon. So when we do that, we want to take off chain, I forgot that word, chain faces, which is like if you have multiple faces, chain faces tries to make like it's a vinyl wrap, it's trying to go on all those faces to be one thing. So if your wing has like 2 faces like this, you do want to do the chain faces. But notice how this one over here, it's getting confused. It's thinking this wing, this part behind here is part of this. So we want to turn that off. And then we press OK. You've added your decal in. Just show the images of the decals. They can either be here, or when you do your rendered drawings, just show that they're there. That should be easy enough for you to demonstrate and easy enough for me to mark it as correct. Now I think that's it for the requirements. Then it's, yeah.
When you get a decal, what file do you have to download?
I think it's most image files. I did it JPEG or PNG. Those are the ones that typically work. It's not an SVG, so not a vector file. It has to be I think it has to be a bitmap to work effectively. Next, you're going to have stuff related to like simulation. Now, do I still have any simulations loaded up on this design? Simulation. Well, one of the things is, what's the dot point you have there with regarding simulation? It's like justifying?
Use simulation software to suggest where failure will occur.
Yes, okay. So, and one of them is also to measure the weight as well, right? So we have this thing over here, material. This is still connected, so I'm going to pick this one because this one's not connected. So I'm going to show you if we change the material. So over here, if I right-click this body and I press physical material, this wing right now should be, I think I've adjusted it to make it aluminium, but by default, Fusion is going to make all your stuff steel. So if it was steel, let's see, if it's steel, your one's going to be steel over here, which is why you have that color of steel. And then you can press, is it inspect? Which one? No, not inspect, sorry. Right click, properties. If you press right click on properties, you have a look at the material over here, and you can even copy this to clipboard to put it straight into your report. It says it's made out of steel, it says what its volume, but it says its mass over here. This spoiler is 150 kilos, I think. I think this is 1.568, so with 5 decimal places. 1,000 to 3. Yeah, this is 157 kilos if this was made out of steel. So that's too heavy for a Formula 1 car. I googled it, Formula 1 car, the spoiler's about 8 kilos on a Formula 1 car. So not appropriate because at some point you have to say justifying how to do the weight of it. So one thing we can do, we can change the material is one design, we can right click, we can go to physical material. In the database that loads up, you can search for a bunch of materials. If you pick a simple metal, like aluminium is a nice simple metal, it's going to make simulation easier. So I just found aluminium, I did 6061 aluminium. I searched it under the metals, and you can just click and drag it over here to the body, and now the thing is made out of aluminium. And now when I right click and do properties, we should see that now our mass is only 57 kilos, right? 1/3 of the weight of steel. Still too heavy because this thing is actually 1 centimeter thick aluminium. Now, that's basically the top of your tables is about 1 centimeter thick. If that was a big piece of solid metal, you'd imagine that being way too heavy. Think of like aeroplanes. The walls of airplanes are only like 3 millimeters thick. Even your car door is not 1 centimeter thick. It's usually shin feet of metal, but they make it thick by having some air gaps between it. So we'll just keep that in mind, but I find the weight here. I'll then go over here to simulation. I'm just going to do a simple simulation for now. I'll go to simulation. I'm not going to simplify any, I'm not going to change any studies. For this particular one, I'm just going to make the bottom of this. So I'm going to assume in my simulation that they bolt the bottom of this to the car somehow with this bottom piece. And then the load, let's just put the load over here. Let's just say, I'm just picking a number. Let's say it's 1,000 Newton. Oh, I thought I read in the Formula 1 that they produce 700 kilos of downforce. So 700 kilos is 7,000 newtons, but I don't want to do that. Let's just say we do, our car is producing 100 kilograms of downforce. So I just press 1,000 newtons acting in this direction of the spoiler, and I press OK. And then if I solve this, solve, we'll see if this gets solved this lesson. Should. Yeah, can you solve? Okay, we come back with our tutorial now. So we put 1,000 newtons on it. It doesn't matter what number we put on. We just want to find, if we put that on there, where those forces are going to be like visible in our design. So over here we have an actual minimum safety factor of 4.36, which is actually very, very high for Formula One. Formula One and racing is in like the aerospace area, where their factor of safety for like the rear spoiler is probably like 1.05. It's actually something that's quite low, because this means that this thing is 4.3 times heavier than it needs to be, basically, is what that's saying. Or specifically 4.36 times stronger than it needs to be, but that also means it's heavier. But what we do over here is we'll see where we can drag this thing down. So that's actually the minimum. So a lot of this is more than 8 times stronger than it needs to be. So we're actually way too heavy. So if we bring this down, we can see where the big issues are. So over here in this corner, right over here, can you see that on your screen? So it says over here, because it says over here minimum, over here this is where the most stress is, because this is where the lowest factor of safety is. And if I actually swap this to factor of safety to stress, we'll see here that's where the stress is concentrated. So that means, as we're racing the car, this is where the crack will likely form. And it kind of makes sense. This is where like an right angle piece is. If you imagine as that's vibrating, or the force, eventually it's going to start breaking, and that's where the little crack will start growing. So I'm saying in my design, that's something that I would have to consider in my design. The next thing, we said our thing is, well, at least 4 times stronger. So even if we fix this by curving this part, our next problem is our object is way too heavy. So there's a way we can fix that, and I'll do it in this spoiler over here so I don't have to modify that design. I want to unlink this, break this link. Yep. So this, we said this was heavy. This is 50 something kilos. We can use the shell function, and what the shell function does, it just hollows out the object. So I want to click this object over here, and let's say I make the inside thickness 1 millimeter and press OK. Now it's going to make a shell. Now you can't actually test this in CAD. I tried it. It crashed the system because it's too too thin an object, and it made too many particles. But we can still use some, and in your reports you can do some approximation, and the approximation is quite good. Firstly, let's see what the shell did. We can use this inspect tool. We can do a thing called, which one are we going to do? Section analysis. So if we do section analysis, we can press this plane over here, and we can drag this across now, and we should, there we go. This is what our shell function has done. It's hollowed out our object. Now it's hollowed it out completely, which that might not make sense, but hey, it's an approximation. So when I press OK over here, oh, don't want that. There we go. Okay, so we've got our object over here. This thing is now hollow. If we right click over here and look at our properties, now we're only 8.6 kilos if we're 1 millimeter thick. But is that going to be strong enough? An approximate thing we can say is if we did our first test and we were 54 kilos, and we could measure the maximum stress we experienced was 63 megapascals, and then our next one now we are 5. So you see how many times lighter you are. 50 to 8 is like 6 or 7 times lighter. So now that we're 6 or 7 times lighter, we would expect the force to be increased by 6 or 7 times. So you can play around with those functions, is a way that you can approximate it. That answers the question for like how you can incorporate weight concerns into your design. And then I think that's it. Then you've got to do your drawings. When you're ready to do your drawings, you go to design, drawing over here. Now I asked for orthographic projections with or without the car, so you're going to have to make different files to do that. One of the files with the car, one without the car. To do the rendered drawing, I'll show you that one so we can get the nice, this one have a livery on it? It does. So when you do the rendered drawing, you can go design, render. Now render should do a nice 3D drawing. It's going to take time to be modeled. It won't be done in time for this lesson, but we'll have a look what that looks like. So what this one's going to do is it makes it look like a 3D, basically does like ray tracing and stuff like that to make this into a model. I would go, I'm not going to run it today, but if I press this button over here and I do all these steps, I press yes, it's going to render, it's going to send it off to the cloud to make the object. I'll see if I do that for you next lesson without the tutorial recording. But it makes object in 3D. It shows you what it potentially could look like in 3D, or basically looks like a high graphics video game. Yes, and then you're going to be uploading the file as we showed there.